Many of you may know about industrial parks like Zhongguancun or Zhangjiang. Even some of you have worked there before, which are vital for urban economic growth. But these areas often face challenges, like balancing industrial needs and urban services, that's we called urban industrial integration. This requires proficient industrial park planning and operations, which encompasses recommending public service sites and planning of industrial zones. Many of you may know about industrial parks like Zhongguancun or Zhangjiang. We know that the emergence of LLMs presents opportunities but also the issues. For instance, if a user query about opening a kindergarten in Zhangjiang, due to missing specific data, a LLM might only generate general considerations. It could even produce non-existent addresses. Moreover, for brand location recommendation, like deciding to open a 7-Eleven, a LLM may not check the vicinity for competing stores because it lacks spatial association analysis capabilities. To solve this, we release the first open-source, multimodal, multi-level, spatial and semantic level, large-scale knowledge graph dataset, IndustryscopeGPT, for diverse tasks in industrial parks. We introduce the IndustryscopeGPT framework. It represents the first implementation of ILM's fusion with geospatial computing and tree-based reasoning on graph databases. Experiments on site selection and industrial park planning confirm that the IndustryscopeGPT dataset and framework enhance the efficiency and adaptability of LLMs. To build IndustryscopeGPT, we followed a 5-step construction pipeline. We started with the spatio-temporal data collection and feature extraction. All the features were then spatially joined, mapping to scales of 100-meter grids and industrial parks. Following this, we constructed relational triples and attributional triples covering 3 quantifiable dimensions. Finally, we used the Neo4j graph database for management. We developed IndustryscopeGPT, an LLM-driven agent that combines text response and tool interaction with graph databases following React style. To optimize decision-making, we use Monte Carlo tree search. Our technical framework tackles a typical siting query. Consider that, I want to open a Bank of China near Chengxing Road. Please recommend a specific address. At the root node, IndustryscopeGPT decomposes the query into the first sub-question. It then concurrently invokes potential tools like Cipher Searcher or GeoEncoder to interact with database and Baidu Map to geolocate the mentioned address to specific grids. New child nodes are generated from the LLM feedback. It might invoke the rank master to sort the identified grids based on their features. In the next depth, MCTS picks the best node for further expansion. The top 5 grids are then decoded, resulting in the top 5 real addresses for recommendation.